All right, so we're in section 10.6 and we're talking about circles and arcs. So the first thing we want to do is talk about what a circle is. We have an idea of what it is, nice round shape, but in terms of math, how do we talk about a circle? So we're going to say our definition of a circle is all points that are the same distance from a special point called the center. And this distance, the distance our point is from this center, is the radius. Guys. So the distance is the radius of the circle. So later on in the year, when we, I think in chapter 12, we'll talk about the equation of a circle. And our equation of a circle comes from the distance formula. So the idea of a circle has to do with this idea of distance. So our distance from the point, from the center to the circle is the radius. The diameter. How do we find the diameter of a circle? How are the diameter and the radius related? Radius is half the diameter. The diameter is twice the radius. So the diameter is 2 times the radius. So 2 times the radius gives us a diameter, or half the diameter gives us the radius. Same idea. So let's draw a picture of a circle and we'll label some pieces. So there's my circle. We name the circle by the point at the center. So we would call this circle P, or this little symbol for a circle, circle P. The letter that we use tells us the center of the circle. Our diameter goes through the center. So that segment would be the diameter. The radius goes from the center to the circle itself. So this would be a radius. And we're going to name this angle. What have we been calling? We've been using this angle with polygons. What have we been calling this angle with polygons? Where our vertex is at the center. That's our central angle. So this is a central angle of a circle also. Central angle just means our vertex is at the center. And that central angle is going to be important when we start talking about arcs. So our diameter always goes through the center. So our endpoints of our diameter are on the circle, goes through the center. Radius goes from the circle just to the center, not through it. We name our circle by the point at the center. Circle P, or this is also read circle P. All right, we good with our picture? So these are pieces inside a circle. Let's talk about pieces that are actually on the circle. Parts on the circle we call arcs. So an arc is a part or a piece of a circle. And we're going to talk about 3 kinds of arcs. And we'll draw a picture here in just a second. A semicircle, when we talk about a semicircle, we mean we're talking about a half a circle. A minor arc is smaller than half a circle. And a major arc is larger than half a circle. So let's draw a picture that shows our arcs. And we'll talk about how we name them. So there's our circle, and there's point P. So this would be circle P. And I'm going to draw some segments in here. All right, what was that? What was that segment that I just drew? That's a diameter. Good. And how about, so that's our diameter, and I'm going to call this point A, this point C, and I'm going to put another point here, B, along the circle. So I'm going to say that arc ABC, and I use this arc. That's my symbol for an arc. Arc ABC. This tells me how I trace along the circle to go on the arc. A is an endpoint. I go through point B, and I stop at point C. That is a semicircle. It's half the circle. Endpoints of a semicircle are always on a diameter. Arc CAB. So this is telling me to start at point C, go all the way around through point A, and stop at point B. That is a major arc because it's bigger than half a circle. And then we can say arc AB is a minor arc. So to name our arcs, we use the arc symbol. For a semicircle and a major arc, we use 3 letters. We use the endpoints and a point between. And the letters tell us which direction we're going around the circle. And for a minor arc, we just use 2 points. This tells us that we go from point A to point B along the circle. So we good there? So I want to draw a picture, and we'll practice naming some arcs, whether they're a semicircle, a major arc, or a minor arc. All right, so let's look at an example. So here is my circle. I'm going to draw a couple of segments. Let me put my center in here. All right, and what's that segment again? Diameter. Another diameter. I'm going to label some points. A, B, D, and E. And we'll call this point C. So the name of this circle would be circle C. The C is at the center. Let's name some minor arcs. So what would be some minor arcs on this circle? What is it? ED. ED. Arc ED would be a minor arc. Arc AB would be a minor arc. How about a couple more? Which one? AD. So right there. Yeah, that's perfect. That's a minor arc, smaller than a half circle. AD. Another one? BE. BE is would be a minor arc. So we're going here to here. So those would all be examples of minor arcs. And we could also go the other direction also. We could say DE, we could say BA. So we can go either direction for the minor arcs. Doesn't matter which order we put our letters in. All right, how about major arcs? What did you say? B. One more time. B. B. D. Would that be a major arc? B. So from B, you're going around this way. So we would need to name one of the points in between A to go around that way. So that would be a. We could say B. E. A. So that tells me I start here, go all the way around to there. So that tells me I go through point E to make sure I go the right direction. I could also name this one BDA. BDA. I'd get the same arc. How about another major arc? E, B, D. Is that what you said? Okay, that works. E, B, D. We're going all the way around to there. Did you have another one, Marcus?
E, A, D.
E, A, D. That works. So that's a major arc from here all the way around to there. That's bigger than a half a circle. So all of those would be major arcs. And the letter in between tells us to make sure that we go. So here if I didn't say BEA, if I just said BA, I would think that we were talking about that arc. But BEA, make sure that I go around all the way around the circle and get back to there. So those would be some major arcs. How about semicircles? E, A, and usually with a semicircle we use 3 points. We could say EA because that either way we go we do a semicircle. Just to be sure we could use 3 points. So I could say E, DA or E, EBA. Either one of those would be a semicircle. Another semicircle. BED. Arc BED is a semicircle. So those two would work because both of those are diameters. Our semicircles always start and stop at the end points of a diameter. So those would be a couple of ways we could name semicircles on that arc. All right. Got a little bit of a feel for naming these arcs? Okay. So in math, what we usually want to do is we want to measure things. We want to be able to put numbers to things. So we want to talk about how we measure arcs. So this is going to be the first example or the first formula that we put in our graphic organizer. So you want to label your top circle. You want to measure it or label it arc measure. So we want to know how we measure arcs. Measuring arcs is really easy. We use the central angle. So the measure of a minor arc. So this would be one of the formulas that would go in there. The measure of a minor arc equals the central angle. So for example, and we'll do an example where we're calculating. The measure of arc ED would be the measure of this central angle. The measure of a major arc. So that you'd want that formula in your graphic organizer. Minor arc equals the central angle. Major arc equals 360 degrees minus the minor arc. 360 degrees takes us all the way around. The minor arc tells us one part, so this tells us what it takes to make up that 360 degrees. So let's draw a picture, and you might want to draw this little picture in your circle to help you visualize this. It's not a, this should fit in your little circle. So one circle for your arc measure. These formulas should be in that circle, and you might want to draw this picture. So I'm going to call that center point P, that point A, that point B, and this point C. So if the central angle is 70 degrees, the measure of arc AB is the same as the measure of its central angle. Measure of arc AB is 70 degrees because that central angle is 70 degrees. The measure of arc ACB equals 360 degrees minus this central angle. So that would be 290 degrees. So the measure of a minor arc is a central angle. The measure of the major arc, we subtract that minor arc from 360 degrees. All the way around the circle is 360 degrees. This tells us what's left over. So make sure you have these equations in your graphic organizer. And if you have room in that little circle, you could draw this little picture to help you remember how it works. What would be the measure of a semicircle? (360) divided by 2, which is 180. Semicircle is halfway around the circle. 180 degrees is halfway around the circle. So the measure of a semicircle is 180 degrees. Another nice thing about arcs is we can add the pieces together. We can add smaller arcs together to get bigger arcs, and we can subtract arcs from each other to get smaller arcs. So just like we did with angles, just like we did with lengths and segments, we can add and subtract arc measures. So let's look at an example using arc measure. So here is my circle. I'm going to draw a few arcs in here and some angles, some central angles. So there's a diameter, goes through the center. And I'm going to call this S, T, U, R, and the center is O. 60 degrees, we'll say that central angle is 20 degrees. And let's find the measure of arc TU. What would be the measure of arc TU? Here's arc TU. So what's that arc's central angle? From here to here? 60. Measure of arc TU is 60 degrees. How about the measure of arc TUR? From here to here. 180. This is a diameter, so this is a semicircle. So TUR is 180 degrees. How about the measure of arc STU? 80. I add 60 and 20. This part is 20 degrees, this part is 60 degrees. How about the measure of arc RU? 120. How'd you get 120? Subtract 60. We know this part is 60. And we know the whole thing around there is 180. So we get 180 minus 60 equals 120. What would be the measure of arc TSU? From here all the way around to here. 300, because this part is 60 degrees. And I subtract that from 360. So I'm going from here all the way around to here. The minor arc is 60, so the major arc is 360 minus 60, and I get 300 degrees. So a couple of examples of finding arc measure. We call this arc measure, or angle measure of the arc. So we're good so far. So like I said at the beginning, lots of little pieces of information in this section. All right, let's talk about next something that should be a little bit familiar. Circumference. What do we mean when we talk about the circumference of the circle? Around the outside. So we're talking about the distance around the outside. What have we called it for our other shapes? We didn't call it circumference. What did we call it? Perimeter. Circumference, we give a special name to the circumference of a circle. For the perimeter of a circle, we call it the circumference. Yes.
Is this on or
We'll put, yeah, so we'll have one, so the next circle you want to add to your graphic organizer would be a circle for circumference. So the first circle is for arc measure, second circle is going to be for circumference. How do we find the circumference of a circle? Let me write this down. This is the distance around the outside. And we've called it, for our other shapes, we called it the perimeter. How do we find the circumference of a circle? 2 pi r. So this formula should go in your circle that you labeled circumference. Circumference is 2 pi r. Or, what's another way? 2. Do we want the 2 in there for this one? What's 2 times the radius? The diameter. So we could say it is, what were you going to say, Matt? Diameter times pi, and we usually write it pi d. R is the radius, d is the diameter. So these two formulas should go in your circle that you label circumference. Circumference is 2 pi r or pi d. And pi is a very special number. Pi is, for any circle, no matter how big, no matter how small, no matter where we are, pi is the ratio of the circumference to the diameter of a circle. So if we measure the circumference of a circle, we divide that circumference by the diameter, we always get pi. No matter how big the circle is, no matter how small it is, the pi is this very special number that comes from the circumference and the diameter of a circle. Pi repeats, or goes on forever without repeating. Irrational number, the digits, the decimals go on and on and on forever without repeating. But it comes from finding the ratio of the circumference to the diameter of a circle. The book talks about concentric circles. What do we mean what are we talking about when we're talking about concentric circles? This word centric gives you a hint. It has to do with their centers. Concentric circles have the same center. So there's circles that are inside of each other, but they all have the same center. So the book will talk about concentric circles. 2 concentric circles this, 2 concentric circles that. They just mean circles that are inside each other that have the same center. So it looks like kind of like ripples on a pond. Concentric circles. All right, let's look at an example having to do with circumference, and then we have one last thing to talk about for this section. So let me see if I can draw a decent set of concentric circles here. There's one. Oh, not bad. Pretty good. They're not perfect. All right. So let's say that the radius of the smaller circle is 7 feet. And the radius of the bigger circle, that whole thing, is 10 feet. And the problem asks us how much further around the bigger circle. And then these two would be an example of concentric circles. So it says how much further around is it around the bigger circle? So what is this problem asking us about? Distance around the circle is the circumference. So this is about the circumference. We want to compare the circumferences. So let's find the circumference of the bigger circle. Circumference of the bigger circle. How do we find the circumference of this big circle? What's our formula? 2 pi r, and r is 10. So 2 pi times 10. When we're dealing with pi, because pi is this decimal that goes on forever and it never repeats, if the problem asks us for an exact answer, or our answer in terms of pi, that's like when we had a problem and it asked us for simple radical form. We do everything that we can with the numbers, but we leave pi alone. So pi is going to stay in our answer. We do all of our multiplication, whatever, but we leave pi in the answer. So 2 times 10, I can multiply all the numbers together, but I leave pi alone, and I get 20 pi feet. That would be my exact answer, or my answer in terms of pi. So kind of like simple radical. The circumference of the smaller circle, 2 pi r, so 2 pi times 7. Multiply outside the pi, leave the pi alone. And I write pi in my answer, so 14 pi feet. So how much bigger is the circumference of the larger circle than the smaller? 6 pi. We just subtract these two. 20 pi minus 14 pi. That was perfect. 20 pi minus 14 pi is like saying 20x minus 14x. I get 6 pi feet. So that would be my exact answer. The exact answer would be the circumference of the bigger circle is 6 pi feet bigger. And pi is a little bigger than 3, so this answer would be a little bigger than 18 feet if it wanted our decimal answer. All right, we good with that example? So remember, exact answer or answer in terms of pi means we do everything outside the pi, basically, and leave pi in our answer. Multiply here. Here we subtracted these two numbers and left pi in our answer. All right, last thing for today, arc length. And we'll have a circle on our graphic organizer for arc length. Arc length is a fraction of the circumference. It's how far we go part way around the circle. So rather than talking about the angles, we want to talk about the distance we're traveling part way around the circle. So our arc length is a fraction of the circumference. So this is going to be the formula that goes in your graphic organizer. The length of arc AB, and we'll draw a picture to go with this, is the measure, the angle measure of arc AB divided by 360. That tells us what fraction of the entire circle that arc takes up. And then we're going to multiply it by the circumference of the circle. And if you want to draw a little picture inside your circle there, we would draw our little circle, and we're talking about the distance from point A to point B, and with a radius r. So the measure of arc AB is a central angle. We divide that by 360. That tells us what fraction of the entire circle that arc takes up. And then we multiply that by the circumference of the entire circle to tell us what fraction of the distance around the circle we go to get from point A to point B.
How do you find out what the radius is?
The problem will give you the radius. You'll have to know the radius to figure that out. So you'll have two pieces of information. You'll have the radius or some way to figure it out, and you'll have to be able to figure out the angle, that central angle also. So you have two pieces of information. That was a good question. All right, let's look at a quick example of calculating arc length, and then we will be done. Lots of little pieces of information, like I said. So our radius here is 4 feet. And we want the length of arc SR. We have everything we need for our formula. So the length equals the angle measure of arc SR. So what's the angle measure of this arc? 100 degrees. Divide that by 360. That tells us what fraction of the entire circle that arc is taking up. And then we're going to multiply that by 2 times pi times our radius times 4. So in my calculator, I'm going to divide 100 by 360, multiply it by 2, multiply it by pi, and then multiply that by 4. So 100 divided by 360, multiply that by 2, multiply that by pi, and multiply that by 4, and I get 6.98. So the distance from S to R would be 6.98 feet. This 100 divided by 360 tells us what fraction of the entire circumference that takes up. And this 2 pi r is the entire circumference. So the fraction times the entire circumference tells me that length. All right, we good there? Okay, homework. Then we'll go over the homework from last time quickly.